talk about geometric probability. So this is how we talk or write what we're talking about on probability of area. We're talking about probability of an event B. That can be written like this: probability of event B. And the probability of event B has a relationship between B and A. I would take the area of B and divide it by the area of A. So if I want to know this, the probability of, I don't know, throwing a dart and it sticks in B, then I would take the area of the area of B and divide it by the entire space of A. We're just comparing the areas. It's a ratio. It's a comparison between two things. What? Compared to the whole entire thing. Okay, let's talk about the area of a sector. This one's a little bit more abstract, but let's talk about what we know about the area of a circle. We know the formula for a circle is pi times the radius squared, correct? Let's talk about a pizza. If you had a whole pizza, that would be 100% of a pizza, correct? But when we're describing a portion of the pizza, couldn't we say a fourth of that whole pizza? That's kind of what we're going to do with this. We're going to take a piece of the whole pizza. So when we're talking about, so for instance, if I want to say I ate 25% of the pizza, couldn't I say I ate a fourth of is multiplying, right? I ate a fourth of the whole thing. Wouldn't that be equal to 1/4? Okay, we're going to use that same reasoning right now with this. So I have the whole circle, which is pi r squared. If I want to know how much this portion of it is, I would take the degree of n, which is this right here, that angle, that degree, and compare that with what? The whole thing, which would be how much? 360 degrees. So this is the area of a sector. N divided by 360 times pi r squared. Kind of make sense? It's just like saying a fourth of the whole thing. Isn't it the whole thing, pi r squared? And isn't this a portion of it? See that? Does that make a little more sense? Yeah? Like I said, it's pretty abstract. That's why I'm trying to explain it like this. Yes. Okay? So you've got the portion, but portion of what? Do you see why we have to do that? You can't just say a fourth of the circle, because every circle is a different size. So you have to say a fourth of this size circle, or a fourth of this size of a circle. That would be two different values, right? Make sense? Okay. Because you know how I like your formulas to have meaning, right? Not just a formula. So that's what it means. Okay, so let's look at this one. A game board consists of a circle inscribed in a square. What is the chance that a dart thrown at the board will land on the board and in the shaded area? Very confusing statement. Basically, what is the probability that the dart is going to end up in this shaded area? All right, so let's check. So we're going to write this. The probability of shaded area? $26. Okay, so in order to find the probability of the shaded area, we have to get the shaded area and compare the shaded area to what? The whole area. So in order to get the shaded area, don't we have to find the square and subtract what? In order to get the shaded area, guys, subtract the circle and divide all of that by, no, by the whole shape, which is the square. Divide it by the square. Taking the square and subtracting the circle would give us just the little corners right there. Okay? So let's go ahead and find these values. So how do I find the area of this square? 12 times 12, or 12 squared. And how do I find the area of a circle? Pi r squared. What's the radius? 6 divided by 12 squared, right? So this would be 144 minus 36 pi divided by 144 equals, I have it here, 0.215. That's your probability. Base times height, 12 times 12. All right, so let's look at another example. Here's number 2. Find the total area of the shaded sectors. Okay, well, I've got 2 different shaded areas. I'm just going to add them together. Okay, so we want to find the area of the sectors. The area of the sectors is 45 degrees plus what? 35 degrees compared to what? 360 degrees, and I'm going to multiply that by how big the circle is. No. Pi times the radius squared. 9. Everybody follow how we did that? Yeah. Okay, so this would be 45 plus 35 is 80 divided by 360 multiplied by 81 pi. And you can put that in a calculator, but I like to simplify first, so that's what I'm going to do. But you don't have to do that. So this would be 4 times 2 times 10 over 9 times 4 times 10 times 9 times 9 times 5. Fours cancel, 10s cancel, 1 9 cancels, and I know I'm left with 18 pi, which is 56.5. Inches squared. Questions? Can we move on? What do you think the next slide is going to be? What? Can anybody guess what the next slide is going to be? The probability of this area. So let's look at, we have 18 pi, right? is our area of just this much. And we also know what the area of the whole circle is. What's the area of the whole circle? 81 pi. Right? The whole, does everybody see that? The whole circle is 81 pi. The sectors added together are 18 pi. Correct? So on the next slide, all I need to do to find my probability of the shaded area, I would just take 18 pi and divide it by 81 pi. That's why I kept it, that's why I originally simplified it. That way, this is actually a very easy problem now, right? I could just factor this, and it's 9 times 2 times pi over 9 times 9 times pi, and the pi's cancel each other out. So do the 9. And so it's just 2 over 9. Well, we're going to put that into a decimal, which would be, quote, 0.22. All right, let's look at this example. So I'm trying to find the area of a sector. I'm trying to find the area of these pieces right here. So in order to find the area of a sector, I would need to find the area of the circle. Subtract what? The hexagon. Then what? Would it equal all the sectors? And then in order to get just the shaded ones, what would I do? Divide it by what?
The circle.
You could divide by 6, or couldn't you just cut it in half? Since there's 6 of them and I have 3, isn't that just half of them? Okay, so let's do that. So how are we going to find the area of the circle? Pi times the radius squared. What's the radius? 6 squared. Minus, how are we going to find the area of that polygon? No. Isn't it what? Half the what? Half the perimeter times the apothem. So if we know that this is 6, right? We know this is 6. We also know that this is how much? 60. Good job, James. Because if there's 6 sides, 360 divided by 6 is 60. True? Okay, so let's compare our triangle and it's a 30, 60, 90 triangle. So if this side's 30 and this side, this angle is 30, then this is the smaller side. If this is 6, how much is this? 3, and if this is 3, how much is the apothem? 3 root 3. So I know the area of this polygon is half. What is the perimeter? Well, if this is 3, then the whole side is, and if their side is 6 and there's 6 sides, the perimeter is 36 times the apothem, which is 3 root 3. I already have these values. Let's do our equal sign over here. I already have these values written down. 36 pi is actually 113.09. Half of 36 times 3 root 3 is 93.42. When I subtract those, I get 19.67. What am I going to do with that?
You're going to
divide
it by 2.
Divide it by 2. Gives me the area of just these shaded pieces right here is 9.8. Well, what do you think the next slide's going to be? Find the probability of it. So I'm going to take this area and I'm going to divide it by what?
Divided by
The whole circle. Good job, James is on it today. So let's take those two values. Take a picture of it. Apply it to the next slide. So I get probability of the shaded region equals 9.8 divided by 113.09. And this is going to be a pretty small number, right? And you get 0.087. And we're done.